Okay, just look around you for a second. The world is this wild mix of substances, right? Things are mixing, changing, reacting all the time. It feels totally chaotic. But what if I told you there's a really simple way to make sense of all of it? Today, we're going to use a little chemistry to turn all that chaos into pure clarity.
So think about this. An ice cube melting in your drink. A nail left outside that starts to rust. You dissolving sugar into your morning coffee. These are things we see constantly. But what's really going on? Well, the one thing they all have in common is pretty simple. They're all changes. But
that's the real question, isn't it? Because understanding what makes these everyday things different is the first big secret to thinking like a chemist. It's how you start to see the hidden order in everything around you. So let's dive right in. All right, our very first tool for sorting out this chaos is this one fundamental idea. See, every single change you can think of, it can be put into one of two boxes. It's either physical or it's chemical. That's it.
so what's a physical change? Well, think of it like this. It's like giving something a new haircut, or maybe putting on a different jacket. It might look different, sure, but it's still the exact same thing underneath. Its core identity hasn't changed one bit.
And all these examples, they fit that idea perfectly. When ice melts, it's still H2O, just in liquid form, right? And when you dissolve salt in water, you can always get that salt back by just boiling the water off. In every single one of these cases, no new substance is actually being created. It's just a change in appearance.
Now, a chemical change, this is a whole different ballgame. This is a total transformation. This isn't just a new jacket, it's like a caterpillar turning into a butterfly. It's something brand new being created from what was there before. This is where the real magic happens.
And you know this intuitively. You can't just unrust a nail to get that shiny iron back, can you? And after you burn kerosene, you're left with smoke and ash. That's definitely not kerosene anymore. Something completely new has been formed, and you usually can't go back.
So this chart just lays it out perfectly. On one side, you're just changing the form. On the other, you're changing the very identity. You know, it really all boils down to one simple question you can ask yourself. Did I make something new? If the answer is yes, it's a chemical change. If it's no, it's physical. Simple as that. So where do we go from here? Well, now that we know how to classify the changes, let's talk about the stuff itself. Because just like changes, all the substances around us can be sorted into two big groups. Almost everything you see day to day is a mixture. Think about it. The air you're breathing, a bowl of cereal, salad dressing. The key idea here is that the parts are just physically combined. They're just hanging out in the same space, kind of like people in a crowded room. They're together, but they haven't fundamentally changed each other.
A compound, though, is completely different. Here, the elements aren't just in the same room. They've actually chemically bonded. They've joined hands and become something entirely new. Think about water, H2O. It's nothing like the flammable hydrogen gas and the oxygen gas that it's made of. It's a brand new thing with its own unique properties, all because of those chemical bonds.
This brings up a really important question. If most of what we find in nature is all jumbled together in mixtures, how in the world do we get the pure stuff we actually need? How do we take that chaotic mess and make it useful?
Well, luckily for us, chemists have developed this incredible set of tools to do exactly that. You can think of this as the chemist's toolkit, designed specifically for sorting out the world. Let's look at a couple of the coolest techniques.
Okay, here's a huge real-world problem. Crude oil from the ground is this thick, black, gooey mess. It's a mixture of hundreds of different things. But from that goo, we need gasoline, jet fuel, plastics. So how do we get them out? The secret is surprisingly simple. We exploit a physical property called boiling point. See, every liquid in that mix boils at a slightly different temperature. So you just carefully heat the whole mess. And the substance with the lowest boiling point turns into a gas first. You collect that gas, cool it down, and boom, you have your first pure liquid. You just keep doing that at higher and higher temperatures. It's a really elegant solution. All right, here's a totally different kind of puzzle. That drop of black ink in your pen, it's usually not just one black substance. It's a mixture of several different colored dyes. How on earth could you possibly unmix those?
The answer is a beautiful technique called chromatography. You can think of it like a race. You put a dot of ink on a piece of paper, and then a solvent starts to creep up the paper. It picks up the dyes and carries them along. But here's the trick. Some dyes are lighter or stick to the paper less, so they travel faster. The slow ones get left behind. And just like that, the ink separates out into a rainbow of its original colors.
Okay, time for a pop quiz. Let's put this all together. Imagine you have a bucket with 3 white powders all mixed up: sand, ammonium chloride, and regular table salt. They look almost identical. How do you separate them back into 3 neat, clean piles? This is where the whole toolkit just shines. You have to use a few different techniques one after another. So, first you gently heat the mix. The ammonium chloride has this neat property where it turns directly from a solid into a gas. That's called sublimation. So it just floats away and you can collect it. Next, you add water to what's left. The salt dissolves, but the sand doesn't. So you just pour it all through a filter and the sand gets trapped. And finally, you just gently heat the salt water, the water evaporates away, and you're left with pure salt crystals. 3 steps, 3 pure substances. Pretty cool, right?
So, we've talked about changes, we've talked about substances, and we've talked about the amazing tools we have to separate them. Now, let's tie it all together and see why any of this actually matters outside of a science lab.
I mean, really, why should you care about chromatography or boiling points? What difference does knowing about a physical or chemical change actually make in your life? Well, it turns out it makes all the difference.
Because this stuff isn't just theory. These are the exact principles that run our world. We use these ideas to make pure, life-saving drugs. We use them to refine fuel for our cars and planes. We use them to get the colors for our food and our clothes. The thing to remember is this. This chemistry is happening everywhere, all the time. It's the hidden engine of our modern world.
And now you have the tools to see it for yourself. So, next time you're in the kitchen, think about this. You boil water for tea. The water turns to steam, but it's still water, right? That's a physical change. But then you toast a piece of bread. That browning, that new delicious smell, you can't untoast it. You've created something totally new. That's a chemical change. See? Now you know why.